Alright, let's have a look at this one. So in A, it says that x equals 1 is the only solution. So therefore we know that comes from x plus 1 factor. So let's see if we can factorise by x plus 1. So here's f of x, and I want to factorise by x plus 1. I might write 1 plus x, put it in order there. Alright, so if I have a look at trying to get this f of x here, you can see the first two terms are 1 and x, so I need to times by 1, because if I times those both those terms by 1, I'll get the 1 and the x. So the next thing I need is an x squared. Oh, if I put an x squared there, I've got an x squared times 1, so now I've got the x squared as well. Tick that off, and you can see here I'm also going to get an x cubed. So each time I'm getting two terms. So the next term I need is x to the power 4, and that again, if I times it by those terms in the first bracket, I'm going to get an x to the power 4 and an x to the power 5. So you can see each time I'm getting two terms, and you can see the terms that we're putting in here are all the even powers, so x squared, x to the power 4, etc. So if I have a look up here, you can see that that is going to be an odd power, so the even power there, if I put dot dot dot, would be x to the 2n. Sorry, that's really bad. And you can see that when I times that one, it's going to be, there's my x to the 2n, and when I times it by x, I'm going to get my x to the 2n plus 1. So that's all fine. So that's fully factorised. And you can also see that that second factor with all those powers that are even powers, x squared, x to the 4, x to the 2n, so they're all like x to the 4 is x squared squared, x to the 2n is x to the n all squared, so they're all squared terms, which we know are all positive as well. So there we've got 1 plus something positive, so we can see that that second factor or second bracket is going to be 1 or greater than 1. So that's definitely positive. And so the only solution we can get to make f of x equals 0 does come from this first bracket where x equals -1. So another way to look at it, if I'm looking at a number line, we know that at -1 it's going to be 0. And we also know that, so if we were drawing it, if I put an axis in here, that's the y, that's the x. If you think about it, to the right of -1, so we know this second factor is always going to be positive, so we've got a positive times this factor here. Now this factor here, 1 plus x, so if I put in anything bigger than a -1, so -1/2, 1 minus 1/2 is positive, 1 plus 3 is positive, so anything greater than that -1 is going to get us a positive answer. So we're going to be up here when we're drawing it. And if I put in anything less than -1, so -2 for example, 1 minus 2 is -1. So this one is giving us our answer, whether it's going to be positive or negative. So when we draw it, we're going to be drawing over that section. Alright, let's have a look at B. So show that this is now a factor of f dash blah blah blah. Okay, so it says f dash of x, so let's go ahead and find f dash of x. So f dash of x, going from this top section up here, so if we differentiate 1, we get nothing. If we differentiate x, we get 1. Differentiate x squared, we get 2x, etc. So we're going to get a 3x squared, a 4x cubed, all the way to a, now if I do the couple of terms before that, x to the 2n plus 1, we're going to have an x to the 2n, we're going to have an x to the 2n minus 1. So if I do that one, you can see we'll have 2n minus 1, x, to the 2n minus 2. You can't see that very well, sorry about that. And then 2n x to the 2n minus 1, and then the last one will be 2n plus 1 x to the 2n. Alright, so we're going to get something like that. Now, if you think about that, this is, you know, 1, 2, 3, etc. So we've got, if I go all the way up to here, we've got 2n plus 1 terms. So that's an odd number of terms. And when I look at, you can see it says show that this is a factor of that. So again, if I look at that as a factor and expand that, it's the square. So I'm going to square the second term, which is 1, square the first term, which is x squared, and double the product, which is 2x. I'm going to write it like that. So I'm looking at that as a factor. Now, when I do that, let's have a look. I'll put it down here first. So I've got 1 plus 2x plus x squared. What I can do first is say, alright, I want the 1 and the 2x definitely, so I'm going to times by 1. So if I times all those by 1, it gives me the 1, which is this term, gives me the 2x, oops, that term, and then it gives me an x squared, but I want a 3x squared. So you can see by using just one term in my second bracket, I've taken care of those two, and I've got a little bit of the next term. I've got a 1x squared, but I need 2 more x squareds in order to get 3x squared altogether. So what I'm going to put in next is, as I said, I need 2x squareds to make up to 3x squareds. So now I can tick that one off. So now I have that one, and again, if I times, so that was using that and that to get my x squared terms. So now if I times that 2x squared by the next term, the 2x, I'm going to get a 4x to the power of 3. Oh, that's that one. And I'm also going to get this bit here, which is 2x to the power of 4, which is a little bit of the next term. So each time I put in another term, I'm taking care of 2 terms, if you can think of it like that. So if I keep going, and you may need to write a few more to help yourself, but the next one would be 3x to the 4, and then if I dot 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 along, you can see it's going in order 1, 2, 3, and it's going x squared, x to the power of 4, so we've got these even powers again. Now, because each term I add in is taking care of 2 terms, and I've got, remember, 2n plus 1 terms, so an odd number of terms, so if I just stick with, forget about that last term for a second, just think of 2n terms. So half of that will be n, because I'm taking care of 2 of these terms with each number I put in. So I only really have to go up to n, and then that would be x to the so that'll be 2n minus 2. If you think about it, how do I know that? I know there are going to be our n terms, because that's half of 2n, even though I know I've got 2n plus 1 terms. And I know, remember, I'm going to get a remainder. So you can see that when I times this by this, or let's times it by 1 first. So we get our n, we get our n lots of, I'll just do that one, n lots of x to the power of 2n, but remember it doesn't give us all of that last one. So I've still got 2n plus 1 left, 2n plus 1 that I want, and at the moment I've only got n. So I need another n plus 1 lots of those x to the 2n's to balance that. Alright, sorry, I don't know if I explained that very well. So what have we got here? If I now rearrange that a little bit, so I've got f dash of x on this side, and I'm going to bring this term over, so minus n plus 1 x to the 2n, then I will get, and I'll put it back into this form, x plus 1 squared, so that's this bracket, times, I'll just put a quotient there, times another bracket. So x plus 2 squared is one of the factors of f dash of x minus n plus 1 to the times x to the 2n. And so hence show that a tangent to this function is never horizontal. All right, so we know that f dash of x equals 0 gives us horizontal tangents. So if I just look at f dash of x, you can see that, well, let's have a look. This term is always going to be positive because it's all to nice even powers here. So all these, so it's going to be 1 plus something. So it's going to be positive, if not, except when x equals 0, it's going to be 1. Now, thinking about this as x plus 1 all squared, you can see, oh look, it looks like if I put x equals negative 1 in there, that will be 0. Hence, this whole term, 0 times something, will be 0. But x equals negative 1 in here does not give me 0. All right, x equals negative 1, again, this is a nice positive even power. So again, I'm going to get a positive answer here. So we know that f dash, well, so we thought maybe negative 1 would give us 0, but that's going to be positive. All right, what about if I look at this term here? It looks like x equals 0 would make that whole term 0. So let's look at that one. When I put 0 in for over to the left-hand side here, you can see this one will be 1, and this, of course, is going to be 1 as well. So it's positive. All right, so there is no chance we can get a negative answer. These are all positive, so f dash of x is always positive, so all tangents must be increasing.